Okay, so simplifying square roots, we just have to know a teeny tiny bit about this, okay? So teeny tiny bit, nothing big on this, so don't get too caught up with it. Something like number 4, you should know how to do easily. What is the square root of 25? It is 5. Right? Now, example 5, square root of 32. Is there a number times itself that gives us 32?
No.
There is not. Well, it is a big, decimal. If we can type it in the calculator, but it's not going to be a whole number, right? So, back in Math 2, probably. Did we do this in 1? I can't remember. We used to in Algebra 1. I can't remember for sure. I don't think we do it in 1 anymore. But I think in 2, you learned how to break these down and simplify the radicals, hopefully. All right. So, I don't think you're going to have to see a lot of this, but let's go over it because we're going to need a little bit of it. Square root of 32. I'm trying to think of, I know the perfect squares, numbers I can take the square root of are 1, 4, 9, 16, 25, 36, right? These are all the numbers times themselves, right? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on, right? I know I'm not going to go any bigger than that. 36 is already bigger than 32. So, we want to try to break 32 down so that it is one of these numbers times another number. How could I break 32 down? 4 times 8 works, but there's a bigger one that will work. 16 and 2. And you want to use whichever one's largest. So 16 times 2. And then when we break this down, okay, we are going to have, let's see, everybody shut your computers. There's too many of you looking at the computer screen, which you don't need to be right now. So everybody shut your computer. Okay. All right. So if I'll do stuff on Desmos up here, and then when we get to work, we won't do a whole lot of work today because we gotta do double notes since I won't be in here for tomorrow. So square root of 16, what is it? 4. It is 4. It's going to be on the outside because you've taken the square root of it. It's not under the square root anymore. But we cannot take the square root of 2, so it stays on the inside. Now, you may or may not have ever done this with negatives under the square root. I think Miss Martin said that she did a little bit of this maybe in 2 if you had her. But you may or may not have seen this. So, can we take the square root of 16? It's 4, right? I just did it over here. Can we take the square root of negative 16? We cannot, because there's no number times itself that would give us a negative number, right? Anything we multiply by itself is going to be positive every time. Like we have negative 3 times negative 3 is positive 9. So we cannot take the square root of negative 16. But we can break it down like we did here by doing this. Negative 1 times 16. Okay, so the square root of negative 1, what does it equal? I got it back on my banner back here. The square root of negative 1 is I, right? Because I love math. That's what my banner says back here. Square root of negative 1 is I. So I love math. Right here, so this math jokes are my favorite. There's another. Did I show you the 4 eyes one back there?
No.
I'll have to look and find that one in a second. But the other one, it's got this little fella right here, and then it's got this little fella right here. It's actually this right here, and he's got on glasses, and this guy is saying square root of negative 16 to him, which is what we're doing right now. Because the square root of negative 1, what is it? I. What's the square root of 16? 4. Usually, we write it with the number first instead of the letter. So it's 4I. So this guy is calling this guy 4 eyes because he has glasses.
Someone ever told you that?
How rude.
Has someone ever told you that?
Huh?
Has someone ever told you that?
No, but if they did, I would love it.
What if Coach Wood told you that? I could see him doing that.
Yeah, I could see him doing that as well. All right, so there's a good insult to throw at somebody out there if you're wanting to bully the sight impaired. I must say, I'm gonna have a hard time sending you to the office if you're calling me the square root of negative 16. You just call me 4 eyes and we'll do math. But if you call me the square root of negative 16, I'm going to be proud of you for knowing that insult and not be upset. All right, so the next one's a little bit more difficult because 150 we can't take the square root of. So 150 we got to break down. We're thinking of these numbers right here. 15, what'd you say? 50 times 3 does work, but can we take the square root of 50? And we can't take the square root of 3. 25 times 6. So we could break this one down into negative 1 times 25 times 6. So if we do this, the square root of negative 1 is I. Why does it keep skipping over here to the big? The square root of 25 is 5. Can we take the square root of 6?
No.
We cannot. We leave it underneath the root. Usually we write it like this, 5I square root of 6. Basically, if you have a negative under the square root, it's going to kind of come out of the root and be an I, right? So if you see a negative under a square root, you should end up with I. We're going to need that in the next couple problems that we're going to do. Okay, everybody okay here? All right. So here's our next problem. Okay. We're supposed to find all of the roots of the function below. So I realize we had check-ins and our minds have not been on this. The word roots, I have not used roots a ton, but what's another thing I could call that? Zeros. They're used interchangeably sometimes. So a 0 is something that will make the function equal to 0. It's also x-intercept if it's real. Sometimes they're not real, though. So what was it we were doing to find those zeros when it was already factored like this? Okay, we could look at the x-axis if we graph it. I don't really want to graph this one because it's already factored. There's another way. If I want to know a number that would make this 0,
Oh, you put the,
plus 5.
The 5 is correct. The 1 is not. Why would the 1, like if I put 1 right here, would it make that 0? 2 times 1 minus 1 would not be 0, right? So what we need to do for these is we're going to set each one equal to 0. So instead of just saying positive 1, we're going to do 2x minus 1 equals 0. We want to see what would make that 0, right? Because if it makes that first part 0, it's going to make the whole thing 0. And so what would I do to solve that? Plus 1 and 2x equals 1. Divide by 2. So x equals 1/2. There's one of them. And you can think, if I plugged it in, 2 times 1/2 is just 1. And then 1 minus 1 is 0. So I get 0 there. This one's the easiest one, this one in the middle, because what makes x minus 5 equal to 0? The positive 5. All right. You can set up the equation if you need to for that one, but you probably don't need to. Now, the last one is more difficult. Because if I plug in, like, negative 25, is that going to work? No, negative 25 squared is like 625 or 12 something. It's not negative 25, right? So let's do the same thing we did with the first part. We're going to do x squared plus 25 equal to 0. And if I want to solve this, what would I do first? Subtract that 25. So I would get x squared equals negative 25. Then what do I have to do to get rid of the square? Not log. If I had like 2 to the x, I would use a log. So x squared, the inverse of a square is a square root. So we are square rooting both sides. When we square root both sides, we put a plus or minus here because it could be positive or negative. What's the square root of negative 25? It's 5i. It's got to have that I because it's negative. So you actually have 4 roots here. You got 1/2, you got 5, and you got plus or minus 5i. Now, one reason that I did not want to pull up Desmos right away for this is because if I graph this, f of x equals 2x minus 1 times x minus 5 times x to the second plus 25. I can see on my graph here, right there's my 0.5, which is my 1/2, right? Right there is my 5. Can I see the plus or minus 5i? I cannot, because those are imaginary roots. They're not going to show up on the graph. Okay? Okay there. So if it's already factored, you can just set each one equal to 0 on that. No, you shouldn't see anything with like a 2 power x here. That stuff makes it not a polynomial, so it won't be combined with this. You won't have to log anything in this unit. No. Okay. All right. Now, this next one is not factored, which means I would have to factor that. But anybody know how to factor something that looks like that? I do, but I do not feel like showing it to you right now. So let's see what Desmos can give us for this. All right, let's see what Desmos can do. Because maybe if all of the zeros are real, Desmos can find the zeros for us. Maybe they're all real. How many zeros should I have for this one? 3. Okay. Okay, so we're going to have to do some more work on this one. This one is not going, we're not going to be able to complete this one completely using Desmos, but we can find one of the zeros. It is 2. All right, so I know one of them is x equals 2. All right, so x equals 2. So, if I have a 0 at x equals 2, that means whenever this is factored like this, I'm supposed to have like x minus 2 times something else over here that I'm not sure about what goes right there, right? But if I've got 2 as a 0, then x minus 2 should be one of my zeros right here. We okay with that? So, let's see what we can do here. If I want to know what should go in this parentheses, I've got to divide. So here is an example. You're not going to have a lot of stuff like this where you have to be able to use long division, but we do have to divide here. So we're going to do 2x to the third minus 4x squared plus 16x minus 32. And that'll be x minus 2 right there. So for this, we're asking ourselves, what times x gives us 2x to the third? And that would be 2x squared. Because if I do 2x squared times x, it gives me 2x to the third. Then I also have to do the 2x squared times the negative 2, which is going to be negative 4x x squared. Okay, we okay here? All right, what do I do next? I divide, multiply, and then subtract, which is actually going to make both of these go away this time. All right, so I can bring down, I actually want to bring down all that I've got left here, 16x minus 32. Because everything went away here, it's going to kind of skip a time here. Now I got to ask myself, what times x would give me 16? What times x gives me 16? 16, right? A positive 16. So I'm going to put a positive 16. So 16 times x is 16x. 16 times negative 2 is negative 32. And then I subtract. That same thing happens. Everything goes away. That's the end of it because I don't have anything else to bring down. Okay? So what this tells me is that f of x is x minus 2 times 2x squared plus 16. Now, x minus 2 gives us the 0 x equals 2 over here, right? I would do x minus 2 equals 0. I'd add the 2 to both sides, or you can do it in your head. And x equals 2. So that is one of our zeros. To find the other 0, I can take this part, 2x squared plus 16, and set it equal to 0. So I want to see what makes that 0. Okay? All right, here. All right, now I got to solve that, Easton. How would I solve that? Very good. So I got 2x squared equals negative 16. Okay, Aiden, what would I do after that? Divide the 2. So x squared equals negative 8. All right, Ayla, what's the last thing? Square root. All right, so I got x equals, it'll be a plus or minus square root of negative 8. What is, oh, can I take the square root of negative 8?
No.
I cannot. So I got to do negative 1 times, can I break down 8? It would be what? 4 and 2. So the square root of negative 1 is I. The square root of 4 is 2. That's going to go on the outside. Can I take the square root of 2? I cannot. It stays on the inside of the square root. So here are your other two zeros. Positive 2i square root of 2 and negative 2i square root of 2. This is probably how it's going to look on like multiple choice if you see something like that. I think you're more likely to see ones like number 8 where it ended up being positive 5i and negative 5i, something that's a little bit more simple. But this could happen right here. There are things even more complicated that could happen, but we won't talk about that. We're just going to hope it doesn't happen to us. We're okay here? Okay, is that the last one on that, or we got another? We got one more thing, don't we? Graph one. Okay. All right. Okay, graph problem. All right, so we can type this into Desmos, and we will to double check it at the end. But you can solve this without typing it into Desmos. On my test, I don't care which way you do it. ACT, way faster to not type this in. Okay? Because this is x minus 3. What's the 0 that goes with that? 3. Okay? Is it a single 0 or a double 0? It's going to be single, which means it's going to cross. There's one you can already throw out. Which answer could you throw out? A doesn't have any single zeros because both of those bounce right there, right? So it's not A. Right here, x equals negative 1. Is it a single or a double? That one's a double. It has a multiplicity of 2 because of that square right there. What are you going to get from that? There's 2 of them there, but you don't even really have to solve this because you're going to get x squared equals negative 4. You're going to square root both sides. Are those going to be real? you're going to get x equals plus or minus 2i. Can you see those on the graph? You cannot. So while you do have those zeros, you can't see them on the graph. So we're looking for a single at 3 and a double at -1. Which one of these graphs has that? C. Right? Because right here, it's a single 0 because we cross. It's a double 0 right here because we just touch. And so C would be your answer. But you can always just type that into Desmos and look at the graphs as well for those. Okay, questions? All right. That's it for those, right? That's the business here. We're going to do... All right. Okay. All right, so we have been looking at equations and finding zeros. We also need to be able to look at zeros and think about what the equation would look like. So, if x equals c is a 0, then x minus c is a factor. Okay? So, for example, if I have a third degree function, f of x, and it has zeros at -1, 2, and 0, then one possible equation for this is x plus 1 times x minus 2 times just x. Here you can put x minus 0, but x minus 0 is just x, right? For that. Or, so that could be an equation because that has zeros at 0, -1, and 2. So if you're starting from the zeros, you're just going to change the sign and write the factors. It is also possible that 3x times x plus 1 times x minus 2 could be an equation for this. Notice here the only thing different is that I put a 3 right there. It doesn't change where the zeros are at. So it also could be possible that a times x plus 1 times x minus 2, where a could be any number, could be the answer for those. Okay, so this is fairly straightforward. Let's look at what the problems will look like. So write a possible equation for a function that has exactly 3 real zeros at x equals 3, x equals 5, and x equals -2. So this is all it's going to look like. Right? If I have x equals 3, that's going to be a x minus 3. If I have a x equals 5, that'll be a x minus 5. And if I have a x equals -2, x plus 2. Now, technically, you can put any number you want in front of this. If you want to put a 4 right here, you can put a 4. If you want to put, oh, didn't mean to do that. Hold on. If you want to put a 7 right there, you can put a 7. Don't put any x's with it, or it'll mess it up. But, you know, might as well go with the most simple right here. Just write it like this. So it could have any coefficient out here, but this definitely would have those zeros. Okay? Now this one's a little bit more complicated. It wants us to write the equation of a function, g of x, with these characteristics. G has a leading coefficient of 2. It is a 4th degree polynomial. It has zeros at x equals 2 and x equals 0 that have a multiplicity of 1, and it has a 0 at x equals -3 that has a multiplicity of 2. Okay, let's start with these last two right here. So we got g of x for this one. If I have a 0 at 2, what kind of factor do I need? I need an x minus 2. What about a 0 at 0? If you want, you can write x minus 0. Now, what is x minus 0? It's just an x, so you don't have to put the minus 0 if you want there. Yeah, you could just put the x, yes. And then both of those have a multiplicity of 1, so that means like your power right here is 1, but you don't have to write that. And we have a 0 at x equals -3. What's the 0 that goes with, or factor that goes with that? X plus 3. That one has a multiplicity of 2. How am I going to make that happen in the equation? square it right there. Okay, so that takes care of this bullet and this bullet. This has a fourth degree because you got one x here, another x here, and then you got two x's here, so there's four x's on that. If we multiplied it out, it'd be fourth degree. The leading coefficient is the number that's in front of your highest power. The way you put a leading coefficient out here of 2, just put a 2 right there. If they had told you the leading coefficient was 7, you would put a 7 right there. So here is your equation. If it is multiple choice, they will probably write it this way. This right here, they probably will not write it as x minus 0. They will probably just make it an x. And so they'll probably also put that first. 2x times x minus 2 times x plus 3 squared. What power? Yeah. So, and like, you got 1x here, you got 1x here, and then you got 1x here, but it's being squared out here, which means it's actually 2. So you got 4x's altogether. So that's fourth power. Right? We could multiply it back together, but there's no need. Okay, questions? If I ask you to write it, it's perfectly fine to write it this way. If it's multiple choice, which it's more likely to be, I would write it this way here. Okay, questions? It's really just going backwards from what we were doing with the graphs. Let's look at what else I have there. Okay, we are supposed to write a possible equation for the graph shown below. So, from a graph, can we see imaginary zeros? It doesn't say that when it has any imaginary zeros, so we're just going to assume it doesn't have any. Maybe it does, but this has just got to be a possible graph, right? They don't give us a lot of detail. They don't really label the y-axis or anything here to know exactly what it is. So, we could do y equals or f of x equals either one. I've got zeros right here at x equals negative 2, x equals 0, and x equals 3. So who wants to try this one to give me the factors that would go with it? Let's see, Drew. What would the factor be that goes with x equals negative 2? Just a 2? We've got to have an x plus 2, right? All right, what about for the x equals 0, Drew? Not x equals 0. The x plus 0 or minus 0, it doesn't matter with 0, right? Yeah, and then the last one, Drew? Nope. X minus 3. Use the opposite sign. So, probably, again, that x plus 0, they won't leave it like that. They'll probably do x times x plus 2 times x minus 3. Now, it's possible that there's a number in front of here. You could put a 7. You could put a 2. You could put a 1/4. You could put a 15. It's possible there's a number there, but I wouldn't make it more complicated than it needs to be. Okay, does that make sense? All right, and here's our last one. Okay. All right. So, this one is giving this to us factored, and we got all of these answer choices here. So, probably your best bet, anytime it's asking what's equivalent, you can type them into Desmos, right? But there is one answer choice we could throw out first. Let's look at how many, I can tell the degree of this. Right here I've got one t, right? I got another t here. I got another t here, but what's happening to it over here? Squared. So how many t's do I have altogether? 4. So, like, we don't count these two separately. This would, like, this 2 squares that, so it means that we're actually dealing with 2 right there. So we got one here, and 2 t's here. So, so we should have 4th degree. So, D's not the answer, so we're not going to check that one. But otherwise, now you could multiply all that back together, but it's going to take a while, so I would just use Desmos. Let's see, let's go over here. So we got 2x times x minus 3 times x plus 2 to the second. And then so plus 2t to the fourth plus 4t to the third minus 8t to the second minus 24t plus 16. What did I do wrong? That. Oh, and I used t's. Why did I use t's? It will still graph it with t's. Right there. So that is not right. So let's try the next one. We got here, that's a plus 2. That's a minus 16. Oh, I wouldn't have, if I had really thought, I would not have checked A either. Because you got that like 2t. So if you distribute, like there's a greatest common factor of 2t. So this one wouldn't have that, but it's fine. We got minus 24t. Let's get rid of that minus 16. Here's our answer, because that is the same graph. So B would be our answer for that one. So a lot of these, there are complicated ways to solve them by hand, but no need for us to spend a lot of time on that when we could just use Desmos for it. That is actually everything for 3.4, correct?
Yes.
Okay. All right, so now let's look at 3.5. Okay. So we're going to do as much of this as we can. All right. Okay, so what we're going to look at for this last part is solving polynomials. So, solving polynomial equations look a little bit different because our questions are going to look, let me skip ahead. Our questions are going to look like this, where we don't have like an f of x. It's not a graph. We just got like an equal sign for solving here. So, let's go over what to do here. The first way we're going to try to solve is by graphing on Desmos, because that is going to be easier than any other method, and if it will work, that's the one that we want to use, right? So that's the first thing we want to try. The second thing we're going to try is factoring, if we can't get it to work on Desmos. Sometimes, and actually anything that will factor perfectly will also work on Desmos, so we won't have to do a lot of those. If we can't factor, we are going to do a little quadratic formula. This says or complete the square because these are Miss Martin's notes. We are not going to complete the square. It is not going to be necessary for us to learn how to do that. And then we could do graphing. This is synthetic division. I didn't teach you synthetic division. I taught you long division instead, because synthetic division is a trick you can use for some types of problems, but we don't have time for that either. But I'll show you one that's similar to this. I could update that slide, I guess, so it matches your class a little bit better. So for these, the only type of solutions that show up on your graph are real solutions. Any imaginary solutions will not be visible. Okay, so for example, if I had like a problem that did something like this, I've only got one real zero. But that graph looks way more complicated than just a first degree function, right? First degree is just a line. That's definitely not just a line. So that tells me there's some other imaginaries that I would have to find out there somewhere. So we'll look at how to do that. But let's start with our easiest scenario. Our easiest scenario is that we can use Desmos. All right. So, if I'm asked to solve the equation 3x cubed minus 12x squared equals 6 minus 15x. Okay? The first thing we want to do every time is just move everything to one side of the equation. I would suggest moving it to the side that will make the highest exponent positive. So like right here, you could do it either way, but I would move everything over here so that that highest exponent will still be positive. So to move stuff over, it just changes signs because you're just doing like subtracting 6 and adding 15x. We like to put them in order, so we'd have 3x to the third minus 12x squared plus 15x minus 6 equals 0. Put 0 because there's nothing left there on that other side. Okay, now what you want to do right here, this line seems unnecessary, but it's really important. Look at the degree and determine the number of solutions. How many solutions do I have for this? It's the same as number of zeros. Your degree is number of zeros. Because what we're really finding here now is zeros because we're going to see what will make this 0, right? When this will equal 0. So there should be 3 solutions. So that's important for when you're graphing it. Because if we graph it and we find 3 solutions, then we're done. If we graph it and we only find 1, then that means there's some imaginary out there that we've got to go find. Okay? So, what we're looking for here, now that this is equal to 0, is really we're looking for the zeros of that function, right? Because the zeros tell us where that equals this. So we are going to go to Desmos, and I'm going to just put it up here. You guys can just watch right now. So if I pull up Desmos and I type in, you want to type in the equation. You can put a y equals if you want. You're going to do 3x to the third minus 12x to the second plus 15x minus 6. Do not put the equal 0 on the end. If you put the equal 0 on the end, it will not graph it correctly. All right, so this graph, how many zeros do you see? 2. So does that mean I got 2 real and 1 imaginary? No, because can we ever have 1 imaginary? No. So this actually, it has 3 solutions, but one of them has a multiplicity of 2, right? So this one, my answers would be x equals 1 with a multiplicity of 2 and x equals 2. Right? And so that has a multiplicity of 2 because it just bounces off the x-axis. And that is 3 solutions. Even though it only looks like 2, it is what we would call 2 distinct solutions. There's only 2 different places where it crosses the x-axis, but one of those is a double root for that. So it's actually 3 as far as solving it goes. Okay? Oh, wait, hold on. Let me go back. So on your solutions, we're going to determine if there are multiplicities. If there are any solutions that are still missing, these are probably imaginary and we'll have to do a different thing. But that worked out. We didn't have to do anything but graph on that one, right? So for most of them, you're probably going to be able to graph. For these 2, let's see, I'm going to do one of them. I'm not going to do both of them. Actually, let me have you guys do these. Open up your computers, type these into Desmos for me. Now, you do need to move everything to one side first. So you have 5x to the 4th minus 35x squared plus 30x equals 0 because this needs to go over to the other side. Whenever it goes over there, you're going to change its sign. All right, so try both of these. How many solutions would number 2 have? It's got to have 4 solutions. Not necessarily. Honestly, Desmos can handle it. If we end up needing to factor it or something, though, it will be easier if you've got them in order. So I like to put them in order. But as far as how you type it into Desmos, it really doesn't matter. Desmos can do it either way. If it ends up being a harder one, it's going to be easier if we have that. So try these two. Don't put equal 0 up on the end. Yeah, do not put the equal 0. So you're looking for. Has somebody got number 2 already? -3, 0, 1, and 2. There's supposed to be 4 solutions. Those are 4 solutions. What would the multiplicity on all those be? Just 1, right? Okay, try the second one. What you've done is fine. Like, if we were trying to put an order, we'd put that one right here. It's not going to matter for Desmos, so. Yeah, well, because you want it to go like x to the 5th, x to the 4th, x to the 3rd, like go descending order. But as far as typing it into Desmos, it doesn't matter. It's going to be the time. All right, what are you guys getting on that second one? -4 and 0. Ugh. How many are we supposed to have on this one? 5th power. We're supposed to have 5 solutions. So you guys got what? X equals -4 and 0. That's not right.
Oh, sorry, guys.
1.391. -1.391. What else? 0 with the. There's nothing that like can guarantee us that it's going to be multiplicity of 4. So let's. In fact, I'm pretty sure it's not. It could be 2. But let's see. Let me look at this one on Desmos. Oh wait, what am I doing? All right, let's type this in. So x to the 5th minus 4x to the 4th plus 4x to the 3rd plus 16x squared. All right, so let's see right here. Let's see now. Oh yeah, that's about all that does. And I need to put this here. All right. Definitely we've got those 2. X equals 0, especially since I know the term that goes with that is just going to be like an x squared. It's probably double. I think this one might have some imaginary left out there. Did I mean for us to go find imaginaries right there, though? I'm thinking I did not. So maybe I either messed up and didn't mean for you to get an imaginary here, or I just wanted us to recognize, hey, this has got some imaginary somewhere, right? So we should have 2 imaginary probably for this. It is also possible that that's a triple root right there, but I don't think it is. So we're not going to work through that because I think I want us to do that later in the problem. So if I'm asked to solve this right here, this one, I think, let's see. Let's use Desmos real quick. We might be able to solve this one with Desmos, but I can't remember. Let's see. Okay, we can solve this one with Desmos, but, and I'm not even saying that I necessarily want you to do it by hand instead, but I think we need to start with a simple one for solving by hand before we try the ones that are more difficult solving by hand, because there are a few where you've got to solve by hand. So if we were going to solve this by factoring, first thing we need to do is move everything to one side. That's going to be the case for all these problems, Desmos or not, right? This one does work with Desmos, so I don't think you can't do it. I just want a more simple example. Then, if I want to factor this, the second thing I've got to do is factor out a GCF. Do I have a GCF here? 4x. So that would be 4x times, I'll have x squared plus x minus 6 equals 0. Okay? Now, I want to try to factor this part. Right? So I got an x here and an x here. What numbers could I multiply to give me negative 6? Negative 3 and 2. I could do positive 3, negative 2, negative 1 and 6, positive 1 and negative 6. Which one do I need to use? Positive 3, negative 2. Okay? So, if I have it factored like this, besides graphing, what could I do? We just did this on the last part. If I want to know where this equals 0, I'm basically finding the zeros, the x-intercepts. So, how do I do that? Set them equal to 0. So, you got 4x equals 0, x plus 3 equals 0, and x minus 2 equals 0. So, like here, you're just dividing by 4, x equals 0. This one's going to give you negative 3. This one's going to give you positive 2. So, again, you can use Desmos on that. I'm not even saying this is a better way. But sometimes I like to give you questions where they've like shown the work and you got to tell where there's a mistake. Also, there's going to be somewhere we've got to factor and we need to be able to do this. All right. Let me look real quick at Desmos at this one. I realize we're about out of time. We're going to do this last problem. Just want to see if this is the one I want to do. X to the third plus 3x to the fourth minus 27x to the second. I'm going to do that one. Oh, I did want to do this one. Okay, here's the reason I want to do this one. Look at my answers for this. I got 0, and that's a double root. But then my other two answers are like crazy decimals for this. And so I don't care about the decimals are okay, but a lot of times they're going to want these as roots. So let's do this one by hand. So I'm going to write it like this, 3x to the fourth. I'm going to put that first because it has the highest exponent, plus 9x to the third, and it's going to be minus 27x squared. GCF, 3x x squared. And that's going to leave me with x squared plus 3x minus 9. And what's going to happen here is you can try all you want to get negative 9, you can only use negative 1 and 9, positive 1, negative 9, and negative 3 and 3. Do any of those give you the 3 in the middle? They do not. This one will not factor. So, if it will not factor, what do we have to use? We did it once the other day. Quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So we got to do negative 3 plus or minus square root 3 squared minus 4 times 1 times negative 9 all over 2 times 1. And you're going to get negative 3 plus or minus, that's 36 plus 9, which is 45, I think. And so the way you're going to see the answer left on this, probably, 45 will break down. 45, square root of 45 can be the square root of 9 times 5. So that could be written like this, negative 3 plus or minus 3 square root of 5 over 2. Now you would still also have that greatest common factor, 3x squared equal to 0, so you get x equals 0. So x equals 0, and then here's your other 2. A lot of times you see the answer left like that on some of these. Okay, that did not get to finding the imaginary ones, so I will let Ms. Hendrick know which ones on the worksheet for you not to do yet because they have imaginary solutions, but you'll have this in a Desmos classroom that you're going to work on tomorrow. Yes? Yes, some of my ROTC is not going to be here.